This lecture will focus on the matrices and KPIs for AI/ML. So one of the important metrics or KPI is the confusion matrix. So basically, confusion matrix is a 2 cross 2 table, which actually shows how well a model predicts the classes. So this is kind of a matrix, 2 cross 2 matrix. So it consists of the components positive component and the negative component, positive and negative, in the rows and columns, and with this, right, we compute the two positive, which we call TP, and the false negative, which we call the false FN. For the false positive, we will get FP, and two negative is the TP. Okay. So from this confusion matrix table, we actually find the accuracy here. So it's nothing but in the numerator TP plus T divided by the entire component TP plus Tn plus AP plus Fn. So accuracy actually tells out of all predictions how many were correct. Okay. Next part is the precision. So precision is your TP divided by TP plus FP, sorry. So if you see the confusion matrix, so this is your TP, right? So one convention you can kind of to remember it, right? Precision, you can see, right, is a down arrow. So that means you can consider TP here by TP plus FP. So this is precision. To remember, recall, is the TP is the same thing divided by TP plus Fn. So if you see the conversion, it is this arrow, right? So that's why I just put here for you to remember. Okay. Now the definition of the precision is that when the model predicts positive, so how often it is correct. Whereas recall says out of all the real positives cases, how did or how many did the model detect. Correct. So this is the basic definition or differentiation between the precision and the recall. Now we can compute the kind of F1 score. F1 score. So F1 score is defined as the twice multiplied by the precision cross recall divided by precision plus recall. So it actually measures the harmonic mean of precision and the recall, useful when classes are imbalanced. So when the class is actually imbalanced, we actually consider the F1 score. Now irrespective of these 4 KPIs below, there are other 2 KPIs which are also very important, right? So one is the true positive rate, so which tells out of all real positive how did the model correctly identify it. Okay, so it is given by the TP divided by TP plus Fn. To remember, right? So this is the TP. You can remember this arrow, right? This positive part, right? It will go. That is the TPR. Okay. For the false positive, that is APR, it is AP divided by AP plus TN. So this you can remember, right? These are from year to year. So this is APR. So this tells about out of all negative or real negative, how did the model incorrectly makes us positive. Okay. Now let's come to the area under curve. So this is basically the kind of in terms of diagram how it looks. So one area under curve is called the ROC, AUC, that is called the receiver operating characteristics area under curve. Another is the precision recall area under curve. So what this ROC curve says, so ROC curve AUC plots two positive rate. against false positive rate. Correct. So in the y-axis it is the TPR versus the x-axis APR. So AUC curve here I have just shown for your example or our example 0.5, which is actually constantly increasing, right? So it shows the probability that a randomly chosen positive samples is ranked higher than the randomly chosen negative samples. So with this definition, right, AUC, if it is 1, it is perfectly classified, shows a perfect classifier. So AUC is 0.5, so as it's shown, right, it's randomly given, right? And if the AUC curve here is less than 0.0, it is the worst classifier in the ROC AUC curve. Now, what is this PR? That is the precision you call AUC curve. So PR AUC tells how well a model perform on the positive class. Okay, especially when the data set is imbalanced. So in case of a, so sometimes happen the while before training or doing training the data is imbalanced, right? So we are not able to know, right, how well it is positively classified. So this KPI tells you in this certain condition. So the curve provides a trade-off between the precision recall, as I mentioned. So in the y-axis is precision and in the x-axis is recall. So generally what happens, PRAC better when it is actually 1. So 0 is the worst case. Baseline is obviously is a 0.05 we can consider in the, for example, a 5%. So in case of these cases, right, so I can vary, or irrespective of this curve, we irrespective of the percentage of the precision recall curve, we can identify whether the model is perfect or worst. Okay. Now this is some examples irrespective you are true positive and false positive, right? So if you see, this is the constant line. AOC behaves 0.4. Here is 0.6, which is slightly better than the actual constant value. Here AOC curve is 0.85, which shows a better value. So if I just compare, right, it is perfectly closer. So if it is reaches 1, it's obviously better classifier. Okay, so thanks for watching this video. So this KPI or AOC or PER or the TPR, APR or these confusion matrix which I have shown are very important, right, while measuring the performance analysis. Okay, so thanks for watching this video. Bye bye.